Okay friends, welcome back. So in the previous session we have seen these standard results. You have to remember them. Okay, I hope you remember them. Okay, let's see some problems based on these results. Let's see question number 32. For LTI system, h of t is equal to e power minus 5t u of t. If y of t is equal to e power minus 3t u of t minus e power minus 5t u of t, then x of t is options are given: e power minus 3t u of t, option B 2 e power minus 3t u of t, option C e power minus 5t u of t, option D 2 e power minus 5t u of t. Okay, so this is what they have given. Let's see. So they have given impulse response and output. They want to calculate x of t. But listen carefully. We are having e power minus 5t impulse response. Output is e power minus 3t u of t minus e power minus 5t u of t. So to get this kind of output, and we are having in the convolution one signal is e power minus 5t u of t, then what might be the other signal? So that might be in the form of e power minus 3t u of t. That is, let's see, we know that e power minus 3t u of t convolution with e power minus 5t u of t, which is e power minus 3t minus e power minus 5t, that is e power minus at minus e power minus bt by b1, in this case 5 minus 3 u of t. So here if you observe carefully, e power minus 3t e power minus 5t u of t, that is nothing but the output, but we are having extra factor which is nothing but 2. Bring it this side, that is 2 e power minus 3t u of t convolution with e power minus 5t u of t. What we are going to get, which is e power minus 3t minus e power minus 5t u of t. So this is what they want to find out, right? So they said this is the output y of t, this is what the output y of t, and this is what the h of t. Then what if this is going to be? This is going to be the x of t. This is what the x of t. So finally the answer is x of t is equal to 2 e power minus 3t u of t. Okay, take it. Let's see some more examples. If x of t convolution with x of t is equal to t e power minus 2t u of t, then x of t is options e power minus 2t u of t, option B e power minus t u of t, option C t e power minus t u of t, option C 0.5 t e power minus t u of t. Which is the correct answer? Directly we know, to get t e power minus 2t u of t, we have to convolve two equal signals, which are nothing but e power minus 2t u of t, again convolve with e power minus 2t u of t. Then only we are going to get t e power minus 2t u of t. So the answer is e power minus 2t u of t. Take it. If you've done that, please try to solve this question. E power minus 60 u of t plus 1 convolution with e power minus 70 u of t minus 4. Try to solve this question. Simple this question is. Let's say first start from what we know. Okay. So what we know is, we know that e power minus 60 u of t convolution with e power minus 70 u of t. So if I do the convolution, we know the standard result, which is e power minus 60 minus e power minus 70 by 7 minus 6, which is nothing but 1. So I am not taking that u of t. U of t. This is what the result we got. Now, in this case, let's assume the signal is x of t convolution with, let's assume the signal is h of t is equal to, let's assume the signal is y of t. Let's assume the signal is y of t. Now see here. Here we are having u of t plus 1, here we are having u of t minus 4. Just try to understand, suppose if I introduce a time shift u of t plus 1 convolution with h of t minus 4, then from the time shifting property, what is the result? Which is nothing but y of t plus 1 minus 4 t minus 3. That's what we are going to get. So try to understand. In x of t function, if I replace t with t plus 1, in x of t function, if I replace t with t plus 1, in h of t function, if I replace t with t minus 4, then we have to replace t with t minus 3 in the y of t function. That's what the meaning of it. So that's what I am doing. So I am simply replacing wherever t is there, t plus 1. So I can get e power minus 6 t plus 1 u of t plus 1 convolution with, I am replacing t with t minus 4, e power minus 7 t minus 4 u of t minus 4 is equal to, so in the output we have to replace t with t minus 3, then e power minus 6 t minus 3 minus e power minus 7 t minus 3 u of t minus 3 u of t minus 3. Okay. Now if you try to understand, here we are having extra terms. What are they? e power minus 60, that's what we require. U of t plus 1 we require. But we don't want e power minus 6. And here also e power minus 7 into minus 4. That is nothing but e power 28. These two terms are extra for us. So bring them out. Then this is going to be e power minus 6, e power plus 28 plus 28. Then e power minus 60 u of t plus 1. Convolution with e power minus 70 u of t minus 4. Then the same result what we are going to get, e power minus 6 into t minus 3 minus e power minus 7 t minus 3 into u of t minus 3. Here we are not doing any modifications. Now here we are having e power minus 6, e power 28, which is nothing but e power 22. Bring that to this side. Then what we are going to get, e power minus 60 u of t plus 1. Convolution with e power minus 70 u of t minus 4 is equal to, so e power minus 22 e power minus 6 t minus 3 minus e power minus 7 t minus 3 u of t minus 3. That's what we are going to get. That is the final output for this convolution. So this extra term is e power minus 22 is there. Clear? Take it. 2 power n u of n plus 3. Convolution with t power n u of n minus 4. What it is going to be. Okay, see this again. We will start what we know. We know that 2 power n u of n convolution with 3 power n u of n, which is 2 power n plus 1 minus 3 power n plus 1 by 2 minus 3 into u of n. So I can replace this 2 minus 3, which is nothing but minus 1. So I can rewrite this as 3 power n plus 1 minus 2 power n plus 1 into u of n. That's what it is. Now if you observe carefully, let's call it is x of n, let's call it is h of n convolution, then it is equal to, let's call it is y of n, y of n. Then if I insert shifting n plus 3, n minus 4 here, that is x of n plus 3 convolution with the h of n minus 4. Then what about y of n? N plus 3 minus 4, which is nothing but n minus 1, y of n minus 1. So wherever n is there, that has to be replaced with n minus 1. Now I am just substituting wherever n is there, n plus 3. Here wherever n is there, that is n minus 4. There wherever n is there, that has to be replaced with n minus 1. That's what we have to do. So if I do that, 2 power n plus 3 u of n plus 3 convolution with 3 power n minus 4 u of n minus 4 is equal to, wherever n is there, that has to be replaced with n minus 1. So 3 power n minus 1 plus 1, that is n, 2 power n u of n minus 1, u of n minus 1. So here we are having extra terms, 2 cube 8, 3 power minus 4 1 by 81. So bring them there. 2 power n u of n plus 3 convolution with 3 power n u of n minus 4, which is 81 by 8 3 power n minus 2 power n into u of n minus 1. That's what we are going to get. So that is the final answer. Okay, take it. If you do this, try this one. X of t convolution with delta 3t plus 2. Delta 3t plus 2. What is the answer it can be? So many people think that it is going to be x of 3t plus 2. That is not a correct answer. First of all, there is no such rule we are having. So first we have to rewrite this expression as x of t convolution with, we know delta at plus b can be written as 1 by mod a delta t plus b. So we could write like this. So if I could write like this, this can be written as 1 by 3 delta t plus 2 by 3. Delta t plus 2 by 3. This is what we can write. So if I write like this, I can take 1 by 3 out. X of t convolution with delta t plus 2 by 3. This is what we know. So this is going to be 1 by 3 x of t plus 2 by 3. So this is what the final answer. Okay, take it. Next question. Again, I am taking example. For an LTI system, x of n is equal to 2 delta n minus delta n minus 3. Delta n minus 3. And h of n is equal to 1 by 2 whole power n u of n. 1 by 2 whole power n u of n. Find y of 1, y of 4 and y of minus 7. These values we have to calculate. Okay. We know that y of n is equal to x of n convolution with h of n. X of n convolution with h of n, that is 2 delta n minus delta n minus 3. Convolution with 1 by 2 whole power n u of n. 1 by 2 whole power n u of n. Now, so because it is a distributive property, to delta n convolution with any signal, same signal, 1 by 2 whole power n u of n minus delta n minus 3. So which is nothing but 1 by 2 whole power n minus 3 u of n minus 3. So this is what the y of n. Now one by one, let's see. Y of 1 If I substitute n is equal to 1, what it is going to be? 2 1 by 2 whole power 1 u of 1 minus 1 by 2 whole power 1 minus 3, that is minus 2 u of minus 2. So u of minus 2 value is 0, u of 1 value is 1. So finally 2 into 1 by 2, which is 1. 2 into 1 by 2, which is 1. Next, you have to calculate y of 4. Y of 4. So y of 4 means wherever n is there we have to place 4. 2 into 1 by 2 whole power 4 u of 4 minus 1 by 2 whole power 1 u of 1. So both exist. So this is going to be 2 into 1 by 16, 1 by 8 minus 1 by 2. So if I take 8 is the LCM, 1 minus 4 minus 3 by 8. Minus 3 by 8 is the answer. Next, if I take y of minus 7, then 2 power 2 into 1 by 2 whole power minus 7 u of minus 7 minus 1 by 2 whole power minus 7 minus 3 minus 10 u of minus 10. We know u of minus 7 value is 0 and u of minus 10 is also 0. So finally the answer is 0. Okay, take it. Differentiation property. Differentiation property. What the differentiation property is saying that I am not giving any proof, directly I am saying that x of t convolution with h of t is equal to y of t. Then what if I do the differentiation of x of t, dx of t by dt convolution with h of t? What it result? It result dy of t by dt. That means if you try to differentiate this one y of t, you don't have to do the differentiation for both x of t and h of t. One differentiation is enough. That means next, in the similar manner, x of t convolution with dh of t by dt. I told you convolution doesn't know which is system, which is signal. Then this is going to be dy of t by dt. Dy of t by dt. Suppose if I do the differentiation of both the signals, x of t convolution with dh of t by dt, what it is going to be? So 2 times differentiation, then we have to get d square y of t by dt square. In general, suppose if I do d power m x of t by dt power m, that means m times the differentiation of x of t convolution with d power n h of t by dt power n. This is going to give you d power m plus n y of t by dt power m plus n. Dt power m plus n. That's what the result what we are going to get. Understood? Take it. So for that, let's say take one example you can understand easily. Example. Let's say r of t convolution with u of t. This result we know. What is that? P of t. P of t. What if I take dr of t by dt convolution with u of t? So from this property, if I do the differentiation of one signal, then that is going to give you the differentiation of dp of t by dt. So let's check it out. Is it true or not? Let's see. What is the differentiation of ramp function, which is nothing but r of t, sorry, u of t. Differentiation of ramp function is u of t. Convolution with u of t. What is the differentiation of parabolic function, which is nothing but r of t. And we know this, u of t convolution with u of t is nothing but r of t. Is it exactly correct or not? Yes, it is satisfied. Suppose if I do differentiation like this, dr of t by dt convolution with du of t by dt. From the property, we have to do the differentiation for 2 times, d square p of t by dt square. So let's see whether it is true or not. dr of t by dt, which is nothing but u of t, convolution with du of t by dt, which is nothing but delta t. Then what is the 2 times differentiation of parabolic function? That is 1 time differentiation r of t, second time differentiation u of t, u of t. Is it true or not? U of t convolution with delta t is equal to u of t. Yes, it is also true. Suppose if I do d square r of t by dt square convolution with du of t by dt. So from the property, 2 times differentiation, 1 time differentiation. So we have to do the 3 times differentiation. Let's see whether it is going to be true or not. d square r of t by dt square, that means 2 times differentiation of r of t, 1 time differentiation u of t, 2 times differentiation delta t, convolution with delta t, 3 times differentiation of parabolic function, 1 time differentiation r of t, second time differentiation u of t, and third time differentiation delta t. Yes, we know this also satisfied. So this is the differentiation property can be satisfied. Okay, take it. Next, very important thing, which is convolution of two rectangular pulses of equal width, two rectangular pulses of equal width. Let's take one example. Let's say x of t (0, -2) +2. This is x of t signal. Let's say this is x of t signal. If it is convolved with a h of t signal, h of t, then what is the result y of t? That's what we have to find out. Now try to understand. These are the two rectangular pulses. What is the width of this signal? -2 to 2, that is nothing but 4 units. Then 0 to 4, this is also 4 units. So I can say two rectangular pulses of equal width. So if the signals are same width and they are rectangular pulses, what is the result it is going to be? Okay. For that, let's go into be very simple procedure. First, we have to calculate y of t, which is x of t convolution with h of t. Now, if you observe carefully, these are having only discontinuities. So I can represent x of t and h of t in terms of step functions. So if I could do that, this is going to be, let's see, what is x of t in terms of step functions. So let's see. At -2, we are having a sudden jump of 2 units. So this can be represented as 2 u of t plus 2. At 2, there is a sudden jump of -2. So downward jump, -2 u of t minus 2. So this is what the x of t. Convolution with h of t. What is h of t? At 0, we are having a jump of 5 u of t minus 5 u of t minus 4. Okay. Now we have to do the convolution, and we are having the distributive property. If I do that, 2 u of t plus 2 convolution with 5 u of t, 10 u of r of t plus 2, because u of t convolution with u of t is r of t, and we are having the shift also. Next, u of t plus 2 u of t minus 4, so minus 10 r of t minus 2. Next, minus 2 u of t minus 2, 5 u of t minus 10 r of t minus 2, minus 2 u of t minus 2 minus 5 u of t minus 4 plus 10 r of t minus 6. So if I club these two terms, 10 r of t plus 2 minus 20 r of t minus 2 plus 10 r of t minus 6. So this is what the y of t. And we know if ramp signals are given, how to represent in the graphical. So this is going to be is equal to zero. We are having how many corner points? 3 corner points. What are they? -2, +2, and we are having another one which is 6. These are the 3 corner points we are having. Now I have to draw this waveform, y of t waveform. How it look like? Let's see. Up to -2, slope is 0. At -2, there is an introduction of slope 10. So we are going to get a line which is slope 10 up to 2. So slope 10. If slope is 10 for 4 units, how much has to be the height? That has to be 40. 40. 40 by 10. 40 by 4, which is nothing but 10. So this is up to this point. Okay. At 2, how much slope was introduced? -20. So already slope is 10 is there. If I introduce -20 slope, then this is going to be slope is equal to -10. At 6, we are having slope introduction of +10. So already -10 is the slope. If I introduce +10, finally this is going to be slope 0. So this is what we are going to get for the convolution of 2 rectangular pulses. Okay, so this is what y of t. To say this, we don't have to do this much of hard work here. Simple way also we can say. What is that simple way? Try to understand. Remember, whenever 2 rectangular pulses of equal width get convolved, the result is always triangle. Once you know what is a triangle, you can understand what is the lower limit, what is the upper limit. How? Sum of lower limits, which is nothing but -2 plus 0, -2. Sum of upper limits, 2 plus 6, 2 plus 4, which is nothing but 6. Then where is the peak point, where the peak occurs, which is exactly midpoint from -2 and 6. -2 to 6, 8 units. So midpoint means from this 4 units, from this 4 units. 6, 4 units less 2, -2, 4 units, that is going to be 2. So this is what the triangle what we are going to get. Next thing, I can call this is a rising edge and this is falling edge. This is rising edge, this is falling edge. If you observe carefully, slope of rising edge and falling edge are same but opposite in sign. Do you know what is that value? 10 minus 10, which is exactly the product of 2 and 5. So this is what we have to remember. So just I am writing those points. Convolution of rectangular pulses of equal width results in triangle. Next, second point, peak occurs at midpoint Next, third point, slope of rising edge is equal to slope of rising edge and falling edge are equal in magnitude but opposite in sign. And slope is equal to product of amplitudes. Okay, these are the points you have to remember when convolution of two rectangular pulses of equal width occurs. Okay, take it. And I am stopping here. In the next class we will continue with this one.